Okay, so here's my setup for Lab 6 and then my setup for Lab 9. I measured the spring scales against the edge of my table, and then I dropped the objects from a marked place on the wall over there. And then here is my table for Lab 6 on the top, and then my table for Lab 9 on the bottom, with all my calculations done. Okay, so in experiment 6 for the post-lab questions, they asked, how did the magnitude of the forces on both spring scales compare after you moved the 10 Newton spring scale? And then I said the 5 Newton spring scale had more force exerted on it after I pulled down on the 10 Newton spring scale. Question number 2 says, how did the magnitude of the forces on both spring scales compare after you moved the 5 Newton spring scale? And then I said for that question, the 5 Newton spring scale made the forces decrease slowly. So every time I moved the 5 Newton spring scale, it would, so first it was like 4.5 newtons, then it went down to 0.5 newtons, and then 0.4 newtons, and then 0.9 as different variables were changed within the experiment. And then question 3 says, use Newton's third law to explain your observations in questions 1 and 2. So Newton's third law states that for every action there is an equal and opposite reaction. And so in response to that, I said with the scales, there were equal and opposite forces exerted on each of them, which caused equal and opposite reactions. So sometimes the 10 Newton scale would drop while the 5 Newton scale rose, like on the pulley, for example. And then question 4 says, compare the force on the 10 Newton spring scale when it was directly attached to the 0.5 kilogram mass and when there was a string between them. So for that, I said when directly attached, the force seemed to be greater because it was a little more direct. And then when attached by a string, the force was weaker because it was not acting as directly. And then question 5 says, compare the force on the 2 spring scales in steps 5 and 6. What can you conclude about the tension in a string? And I said the tension in a string causes the 2 forces to become unequal. So like on the pulley, the string kind of pulled downward with the 10 Newton and then pulled upward with the 5 Newton spring scale. Okay, and then for Lab 9, I basically just used a piece of tape, marked a little spot on the wall, and then timed different objects as I dropped them from the marked piece of tape. And then for those post-lab questions, let me see here. The first one says, how does the rate of acceleration you calculated for each object compare? Are they similar or different, and why? And I found that the cork, marble, and block all had kind of like the mid free fall time of 0.5 seconds. The coffee filter took a little bit longer, and so did the baseball, so they were both at 0.7 seconds. I think because the baseball's heavier and then the coffee filter tended to float, and then the popper took the least amount of time. And the second question says, compare the rate of acceleration for the objects with the acceleration calculated in pre-lab question for the acceleration at the Earth's surface with percent error calculation. How do they compare? And with that, I think it's just that gravity is calculated at 9.8 meters per second squared. And then with this, the gravity seemed to not have like as large of an effect on it because I dropped it from a pretty like low kind of point on my wall, so it tended to be less than 9.8 meters per second squared. So yeah, that's it.